Can you see that? Will it focus on my phone if I hide my face? There we go. A-Bomb 79. Like my video. How's it going, guys? We are going to be talking about machining some CNC stuff. This is something that is pretty new to me, but I've been doing it for a little while now. A couple months I've been working on some stuff. I've designed my own quad frame, and I have I've been trying some other projects and stuff, just working on figuring out how the CNC stuff works, and also how to do it a little better and then make the process more streamlined and stuff. So what we're going to be talking about today is some of the cam stuff. I'm going to show you guys how to create a basic tool in Fusion 360, as well as a tool holder, because Fusion 360 does not have an ER11 call it chuck by default.
Welcome.
We're going to I need to make one of these really little bits, one of these little tiny guys here. If I hold it in front of my face, will you see it? There you go, that little tiny guy. I also need to do this 1/4 inch router bit, and I'll make a cam profile. Before we do that, what I want to start with is how to set up a tool in Fusion 360. It's not super complicated. It's the easiest way is, or it's what am I trying to say here? It's not that complicated, but you'll want the specs for your tool, the tool that you're putting in there. That's going to be very helpful. The more confusing part that for me was the actual tool holder. So we're going to do that also. I haven't seen one video yet that's doing them both in the same one. That was the most helpful for me, at least. So hopefully the way I explain it can help somebody out there better than any of the videos that are there. So we're going to jump into Fusion here. So you can see right now I have the this is the Source 1 frame. It's the TBS design, and I have been working on cutting some pieces for this frame because I want to try some stuff. When you open Fusion, usually by design it's going to be, or by default, excuse me, it's going to be in the design workspace, because that's where you do all your drawings, you make your models, all of that stuff. So what we're going to want to do up here in the upper right corner, you're going to want to click on where it says design and just go to manufacturer, give that a click. So that's going to take us to our manufacturer workspace. So this is where we can do our cam profiles for either a CNC machine. You can also set up profiles for 3D printers, which is pretty interesting. And it'll let you do things like simulating the tool path and stuff like that. So before you take it out to the machine, you can see if it looks good. If it's doing anything funny that you don't think is going to work out or you don't want it to, you can simulate that before you actually stick the SD card in the machine and start your cuts or your prints. So once you're in the manufacturing workspace, we're going to want to go up to the upper right hand corner, and you'll see a little icon that looks like some tools. You want to click on that. That's the tool library. That is going to bring up this screen here. And you can see, since we're working on a project that's up here, these are all the tools that I've used so far in this project. Down here are the rest of the tools and stuff that are in the library by default, and this is all of the tools, including scroll forever here. This is all the tools, including yours, that you've added into Fusion. So what we're going to want to do actually here, because we don't care about the Fusion library at the moment, we're going to go to library. Now, if you don't have one, it should have the local one, but by default, it'll just be empty. If you want to add one for a specific project or anything like that, you can just right-click and say New Library and go from there. You can also duplicate the library and so on if you want to use some of those tools, all that. So what we're going to want to do, once we have library selected here, you can see all of the tools that I have created so far. We are going to start with this 1/4 inch bit because it's really simple. So you're going to want a measuring device. Calipers are going to be great. If you don't have that, a good metal rule will suffice, but calipers can be pretty handy. So we're going to come up, click New, and we're going to be presented with a bunch of just default like templates. We're not going to be doing a holder, so you don't have to go down that far. It's not a probe or anything. We are going to be looking for so I guess we're going to go with a flat end mill because that seems to be the closest to what we're doing here. So once you click on that, it's going to bring up the window for the actual tool. If you have this actual information, it's a good idea to go ahead and put it in here just so you know exactly what tool it is in case you have two similar tools, or you need to get another one and you don't remember where you got it, all that stuff. So you can put in a description. This is a 1/4 inch router bit. I think this is high-speed steel, so we'll say HSS router. Router bit. And we don't know the vendor or product or any of that stuff. If you know the product ID, like the part number, it's a good idea to put that in there again, because if you have to get a new one, you can just search the part number. If you have a link to where you got it, you can chuck that in there for the same reason. Next, we're going to go to the actual cutter itself. So if you decide you wanted to change it to a different one of those other options that it gave you, you can click the drop down and you can change it here. We're going to leave that. This is, so it's a 1/4 inch bit, but we're going to go ahead and leave it millimeters because everything else in the project and everything I'm doing is millimeters. Even though I am an American and I love freedom units, millimeters, frankly, are a little bit easier to design with, so that's what we go with. Number of flutes. This is the number of slots or grooves, effectively, the number of cutting surfaces on your tool. So this one, it's 2. I don't know if you can see that here. Will it focus? It did sort of for a second. So there's 2 cutting surfaces, 2 slots going up there. That's 2 flutes. So we're going to change that to 2. It should be a clockwise. Yep, it's a clockwise rotation. That's pretty standard. So we'll leave that checked. The material is what the tool is actually made of. In this case, I'm pretty positive it's just high-speed steel by the look of it, and it was cheap. It's not coated with anything. It's not carbide, and we're way too broke for ceramic tools. So we're going to leave that at high-speed steel. So here's where we get to the meat and potatoes of the actual tool itself, and that is the dimensions of the tool. So what we're going to do, we're going to break out our calipers here, and we're going to measure here, and we're going to call that 5 3/4 or all the way to 6, because we want to measure where the cutting edges are, basically. So we're going to call that 6 1/3 actually. So 6.3 millimeters. The shaft diameter should be the same, but it's good to check. Oops, gotta get on the actual measuring surface. Yep, 6.3. The overall length is the total length of the tool. That one's a pretty easy one to measure. go. That is going to be 51.3. 51.3. Length below the holder is the part that is going to actually be sticking out below whatever you're holding it with. In this case, an ER11 collet chuck. This particular bit, I'm going to take it right up to the end of the flutes, basically. So that is going to be, we'll call that 23 and a half. 23.5. The shoulder length is basically the length up to the end of the well, where the shoulder is. Basically, it's kind of the end of like the grinding on the tool. Let's see. In this case, it would be like right before it flares. Up to where it flares. So from the flare down, basically all the way to the tip. I don't know how well you can see that. So from that kind of the top of that shoulder all the way down to the tip of the bit. So we're gonna go here, and that's gonna be actually just a tiny bit shorter than the end of the footage on this one. So we're gonna go 20.75. And honestly, for most cases, like these lengths aren't super critical. If you're using a more advanced machine, it probably is. But again, all of this is going to come in the data sheet with your tool. So if you're using a more advanced machine, you're probably using a little bit, excuse me, better tool than I have here, and it should have a data sheet. So you should be able to look that up and just punch those numbers in here. So the flute length here is going to be the same in my case as the length below the holder, but it might actually gripe at me here, which, let's see. Yeah, okay, so the shoulder length must be larger than the flute length. So we're going to swap these basically. Let's see. Yeah. So we're going to make the shoulder length the same as the length below the holder, basically, and it should be fine. And then we'll make the flute length the 20 and 3/4, 20.75. So there's our tool, and you can see on the right-hand side here, it gives us somewhat of a preview. It's kind of a generic thing because it's, you know, acting as if it's cutting a cylinder, which it sort of is, so you don't have to see all the flutes and so on and so forth. The next thing is the shaft. I don't really do anything here. I don't know. I guess it could be that, like, if it's like a brazed on ceramic cutting tool on like a high-speed steel shaft or something like that, then I suppose you would need to do that. The holder, in this case, I have an ER11 collet chuck already designed, so I'm going to select that one. And you can see the preview here is going to change, and it's going to look kind of similar to that guy there. The cutting data. So this is going to be the speed at which, like your speeds and feeds and all that stuff for the tool. So in this case, the spindle on my machine, it is the 20,000 RPM spindle, but because I haven't put upgraded to a newer or better power supply, it doesn't quite get it all the way up to 20,000. So we're going to spin this at 14,000 RPM. And ramping, yeah, no, we're going to keep it because we want to keep it at a steady 14,000 RPM. So we're going to keep the ramping speed the same as well. Cutting feed rate is where we're actually going to want to cut that way down. So we actually want to go to about 120 millimeters a second. Should be pretty good. And you'll see all that the other stuff will kind of update automatically, except for the ramp feed rate. And I usually just keep the ramp feed rate the same. It seems to be okay. If anything, you want it to be a little bit slower, it seems like to me, because it's actually while it's diving as it's moving. The plunge feed rate, again, if it's going in, for this particular type of bit, we're going to want to keep that like really slow. Not quite like 1 millimeter a minute kind of thing, but probably like 10 millimeters a minute. That should be awful slow enough. So, let's see. We're not going to be using any coolant because this machine doesn't use coolant, so we're going to disable that. And yeah, we shouldn't really have to worry about the step down, step over stuff. The post processor. Oh, okay, yeah. So this is like if your machine does has automatic tool changing and stuff. We don't have to worry about that. So now we just hit accept, and now you can see we have our 1/4 inch high-speed steel router bit. So that is making a tool. I probably made that way longer than really is necessary, and maybe even more vague than it should be. But hopefully it's as simple as it needs to be, and clear enough that you can get your tools into here. So next we're going to go over how to make the tool holder. What we're doing now is we're going to be making a tool holder. So in this case we're doing the ER11A, according to the net, call it. And this is not in the Fusion library by default, which is not entirely surprising because it's mostly like a router chuck and like small tool thing, and Fusion honestly is geared for bigger operations. You can use the personal license like I am now, which because my student license finally expired, which is sad because the student license actually has all the stuff, so all the rapids are gone. That's the biggest thing, so the machining process takes longer. For me anyway, that's the biggest thing. Anyway, so we're going to be making that tool holder. As I showed you before, I do have one made already, but I want to make another one. So, just so we can demonstrate. So what we're going to do, we're going to go back up here. We're still in the tool library. Going to go back up here to the upper left and click the plus symbol for new. And this time we're going to select holder. And this is a little bit of an interesting thing, and it confused me until I finally found a video that sort of explained it, and it was decent. So I wish I could remember what video it was, because I would leave a link in the description. If I can find it, I will do that. So anyway, same thing here. When this window comes up, you're going to have description, vendor ID, all that stuff. If you have that available, chuck that in there. It's good to have. Next is going to be the holder geometry. And this part is the part that isn't necessarily just straightforward if you've never had it explained. Once it's explained, it's like, oh yeah, that makes sense. So basically what you're doing is you're going to be creating a series of cylinders and cones that are stacked up to create the outline of your tool holder. So in this case, again, the ER11. So what we're going to want to do, excuse me, is there's going to be like a couple of stages here. So we're going to have to kind of break that down into separate measurements. So what we're going to do, we're going to start from the top of the holder and work down. If we're looking at it this way, it's going to be bottom up, but considering it's normally oriented that way, it'll be top down. So first, we hit the plus. That's going to give us generic 10, 10, 10. We definitely don't want to stay with that. So we're going to take some measurements here. We're going to show the base of the motor itself, because on the machine it does stick out just a tiny bit. So let's start here since we're on the height. Measure that. So we're going to call that 6 millimeters. And this will make a little more sense as we go on here. So 6 millimeters high, and the diameter of the motor is 42 millimeters. And because we don't want any taper there, it's going to stay 42. Okay, so now we got that little base the base of the motor there. Okay, so next we're going to show the little nub on the base of the motor there. So we're going to hit the plus symbol, and it's going to show us our copy. Hangnail. It's going to copy the previous one, which is fine. We just have to modify it now. So this is going to be 4, 17, and 17 from our previous measurements. And now you can see it's starting to look like a little top or button or something from the side. Okay, so that's the base of the motor to where the shaft of the call it chuck begins. So we're going to see if we can get on that shaft, get a measurement there. If not, we'll oddball it. Looks like it's probably a 6mm shaft. Yeah, 6mm shaft. And then we're going to want the distance in between there and call it chuck. 2.7, call it 2.5. So we're going to copy that, and it was 2.5 millimeters tall and 6 millimeters in diameter at the top and at the bottom. Starting to come together now. So we got that little tiny piece of just a shaft, which it would be nice if it wouldn't require a big chunky motor to make this shaft go all the way through, but it's what you get when you're working with a small machine. Okay, so next we're gonna start on the next one here, and we're going to the actual call it chuck part here now. So that is gonna be 16 mil. Seems about right. Let's see. Yeah, 16 mil diameter. Oh wait, hang on. That starts with height. That's okay. We'll go to 16 mil and 16 mil here, and then we'll go back to the height. Okay, so the height is this way then. 20 millimeters. Okay, yeah, so it's 20 millimeters. There's a little shoulder there. I don't know if you can see that. And that little shoulder there is going to be our next cylinder, like where that starts. So it's going to be 20 millimeters tall. So we're going to go add. And right there, if you wanted to be really accurate, you could put all the little tapers in and stuff. They're so small on this thing, it's unnecessary. So the next one, it's going to be 14 and a quarter in diameter. We'll just call it 14 quarter of a millimeter. It's not going to be a big difference here. And then the height is going to be to the base of the nut there. That is 8.8, we'll call it 9 millimeters. Alright. So now we're going to do the profile of the nut itself. And we'll get a tiny bit detailed here just so we can show the little bit of like chamfers and stuff for the hex cuts and the tiny little bit of a bevel at the bottom. Just because that's closest to the tool, will be a little teeny bit more accurate there. We're going to call that 7 millimeters. 7 millimeters tall. That's going to be 19 millimeters in diameter. Alright. Next part where the actual hex cutouts are, that is going to be 5 millimeters. I believe this is a 14 millimeter, or no, 17 millimeter. Yeah, 17 millimeter hex. Okay. And then the final little tiny part, which is the taper. So that's going to be just 1 mil tall. It's going to be 17 mil at the top, and we're going to taper down to 14 millimeters. There you go. So now you can see the tiniest little taper at the bottom, which kind of reflects our actual cullet. So again, what we're doing here is basically just creating a series of cylinders, which is what we have here, and we're stacking them up to make the profile of this. So as if you're looking at it just like it is, just from the side on, that's what this will be. And then Fusion is going to make a 3D cylinder stack basically to represent this in your wow, in your manufacturing workspace. There you go. When you're doing your cam profiles and stuff, which we're going to get to in just a moment. So now that we have all of that set up, since I think I am actually going to keep this one, we're going to go back here. We're going to call this a Sane Smart ER11. Call it Chuck. The vendor is going to be Sane Smart. Product item GS-775M. And oops, let's just copy this link. And then we say accept. So now what we can do is when we are setting up our cam profile, it's going to ask us to select a tool, and we can say which tool, and we can say which holder, or we can even just say which holder each tool is going to use. So let's go in here, we'll edit this, and then we can come over here and we select that holder. There we go. And now it's going to use that one in the cam profile when I select that tool, because it's just automatically associated. So I'll probably have to go through and change all of those for all of those tools, because I think that is the one I'm going to want to use, because if you look at it, to me, that looks pretty close to that bad boy. You know, that looks pretty good. So I'm going to use that one from now on, I think. Thanks, guys. You helped me out. Appreciate that. But that is creating a tool holder. So next thing we're going to do, now that we have that all done up, we want to make a cam profile for this top plate here. So the easiest way I have personally found is to basically start with all of the other bodies or components or whatever just hidden. Just turn them off, and we're going to work with this one part. So right now we have the top plate selected here. You can see it is highlighted. What we're going to do is we're going to come down here to setups. We'll actually go ahead and shrink that. We're going to go to setups, right click, say new setup. And what it's going to do is by default it'll try and use the same setup basically as your previous one, and I think that's in case you have to do multiple operations on the same piece, which is actually kind of a neat feature if that's what you're doing. Thankfully these parts are simple enough that I can do everything basically in one operation. So what we're going to do is we want to make sure we have our machine selected. I do have Sane Smart. We're not covering the machine setup right now, but you want to make sure that you have it selected. So you click on select your machine. That's the right one, already selected, so I'm not going to change anything there. We're doing milling, so that's fine. Let's see. Orientation, model orientation, stock box point, all that. That's fine. And we're actually going to change something there. So we're going to come back to that in a moment. So here we go. So we're going to go to stock. We're going to change that to, oh, which one is it? It's relative size box. Yeah, there we go. We're going to take, we don't because we don't need to like mill off any excess material, which I probably could do in some things, we're going to change this to 0 and 0, and we want to, yeah, that's fine. Then we're going to come back here. We're going to select our box point for where we want our machine basically to start, or how it's going to be oriented. So it's going to be there. I think that's everything we need to do for the setup. So we hit OK, and now you can see that there's this box around here. That's here. So what we're going to want to do, we're going to do a 3D contour, and that's going to be the best for this particular cut or operation, just because it'll get everything done for us all at once. We don't have to do an operation for pockets, an operation for holes, and then an operation to cut out the border. This will do it for us all in one shot, which is really nice when doing a flat plate like this for a drone frame. So we go up to the top, we click on the 3D contour. We're going to select the tool that we want to use for this one, which is our 1 mil. That was one of the one I did offline after I made that 1/4 inch one earlier. All the feeds and stuff should be good because they're part of the tool, or they're established under the tool, so that should be good there. So next, we're going to go to geometry. We want to do a tool outside the boundary of our silhouette. That will keep our part from being undersized, so it'll cut to the outside of the line as opposed to just down the middle of the line. So it cuts down the middle, then half of the tool width will, it'll reduce the part size or make a hole bigger by the width of half of the tool bit. So we don't want to do that. So next we want to go to our heights tab here. I'm going to knock the clearance height down to 4 mil above the retract height. Retract height is fine at 5 mil. That means it'll come up 5 mil above the work surface to when it has to move and things like that. The top height is the top of the stock that was established in our setup, which is the same as the part or the model, so that's good. We could alternately select model top and it would be the same because they equal basically. The bottom height is model bottom, or you could do stock bottom again because they're the same height or the same elevation, I should say. But we'll leave those. We'll just leave it at model top, and model bottom is fine for now. Next, we're going to go to passes. The only thing we really need to change here is our step down, which is basically the how far it's going to go down per pass. So we don't want to go quite a mil. I normally go at about a 1/2 mil, or I've been going at about a 1/2 mil. I think the machine can go just a tiny bit more than that, and probably especially with this smaller bit, so I'm going to go 0.75. Only 1/4 of a millimeter of a difference, but it can make a difference, especially on a machine with a shaft diameter that small. When you're putting force on there, plus all the plastic parts for the mounting the spindle and all that stuff. We're going to do order by depth, and what that'll do is it'll make one pass on everything, then do the next pass on everything, and then the next pass, and it's going to only go down that 1/2 mil per pass. And what that allows it to do is it'll finish all the holes and everything before it cuts it out all the way, so that the work or the piece can be held in place while it's finishing all the pockets and holes, so it doesn't move around and you don't have to reclamp or anything else like that. So next we're going to go to our linking. Let's see. I usually just leave that at full retraction. That's fine. We can preserve the rapids. Because rapids kind of don't work anymore with the personal version. Do I want to always use high feed? we're going to preserve the rapids for now. I'm going to make a separate one with that and see, just test it. Why not? Let's see. I don't really have to worry about the stay downs and stuff in our case because everything is, you know, plenty far away. Lead-in transitions, those are fine. The ramp, I'm going to change the maximum step down per revolution of the ramping profile, so each time it goes down, the max it will go down. We're going to make that match 0.75, and the rest can either auto-calculate or should be okay. Let's knock the ramp clearance height, so basically where it starts to ramp down, we'll make that half a mil. Instead of almost 8/10 of a mil. Then the ramp diameter can stay. We're going to leave the entry positions off because I think what it does on this machine is it makes it go like, and it, like when you set up the machine, it drags across the surface to the workpiece and then it comes up and then starts going. So we're going to leave that blank. I'm going to test that here and there too. So that will say okay. Now you can see it generates the toolpath. All the yellow lines are where it's going to lift up and travel. The blue lines are cuts. And let's see. So leaving the entry position off too, it moves all the way over here. So we might actually want to go back and do that. But we're going to go ahead and simulate this real quick. And you can see it's going to cut all the way around. And then we're going to pick up and it's going to do all the pockets. Sometimes it slows down because it's ramping in. And then it's going to make another pass. Let's look at it. Looks like it can actually cut out these dog bones all the way as well, which that's cool. Make it all the way around. Going. We'll wait until it goes to the second pass here. So there we go. So now it's going to the second pass around, and you can see it's going to go do that all the way until it gets to the bottom. Let's see. Yeah, that's skipped it. Okay, anyway, so it will end up cutting out the border last, which is ideal for this, like I said. So that way it's not moving the part around while it cuts out the pockets and the holes, and so you don't have to reclaim. So that's it. So now everything should be good. I think, like I said, I'm going to go back. We're going to edit this one last time. We're going to set an entry position, and pick that spot right there. That should be okay. So that way, if it does still do its weird thing where it's like drags across the surface for whatever reason, it's not going to be drastic. It'll only be a couple of millimeters away, basically. So there you have it. That is how to basically do a basic 3D contour toolpath for a flat plate, and how to set up a tool and a tool holder. And next I'm going to try and make another video, and we'll see if we can show the cutting process and all that stuff with the machine itself. And hopefully you guys have found this helpful. Hopefully it was enlightening. Hopefully it just was, if nothing else, a different perspective, and it got it to click for you if you were struggling. If you have any questions, do go ahead and leave them down in the doobly-doos, and I will do my best to get back to you. And if I have the answer, I will give it to you. If not, I will try and point you in the direction of somebody who I think probably does have that answer. Otherwise, I will apologize profusely for not knowing at all and doing a video that dared to broach a topic that I'm not nearly prepared on. So, again, hopefully you guys enjoyed this. Hopefully it was helpful. Have a good one. Take care, guys. Be safe. Even these little machines can be dangerous if you're not paying attention. and if if you let it get away from you. All right, guys, happy machining. Have a good one.